Hello, everyone, and welcome to our webinar, Kickstarting Your Unified Namespace with real devices, with real data, and hopefully real easy. Hello, my name is Arlen Nipper, and I'm joined by Benson and Dan from Opto 22 today. So just a quick introduction about me. Arlen Nipper, and I've been doing industrial automation for the last 46 years. So I've seen just about everything with devices, network infrastructure, real-time, mission-critical SCADA systems. So what I'd like to do right now is, Benson, have you and Dan introduce yourselves very quickly.
Sure, Arlen. Thanks for having me today. Great to be with you. My name is Benson Hoagland with Opto 22, responsible for marketing and product strategy here at Opto, where I've been for about 30 years and in the business of industrial automation for about 38.
And I'm Dan White. I'm Director of Technical Marketing. I work with Benson at Opto 22 as well. I've been there for about 12 years. Before that, I was for about 7 years a customer working with automation products in a real manufacturing setting. And yeah, look forward to sharing some great stuff with you guys today.
All right, great. Thanks, Benson. Thanks, Dan. Appreciate it. So, just a real quick introduction about Cirrus Link. Basically, Cirrus Link was started because we wanted to provide MQTT-centric software for real industrial automation solutions. Andy and I invented MQTT in 1999 on a SCADA project for Phillips 66. And then it kind of languished for a while within IBM, and then it started kind of emerging as an IoT, a consumer IoT with Facebook and other applications. But we really were looking to get it back into the environment it was originally invented for. Fortunately, we were able to become the only strategic partner with inductive automation. And so really what Cirrus Link does 5 days a week, 8 hours a day, is we develop MQTT technology modules that run on the Ignition platform. Now, in addition to that, we have Chariot, our standalone Sparkplug aware MQTT server, and something we'll be going over very briefly today, the IoT bridge for Snowflake. Now, a little bit about MQTT, just what are the benefits of a stateful publish and subscribe infrastructure? Well, right off the top is that if you have a stateful infrastructure where you can do report by exception, that results in 80 to 95% bandwidth reduction in the sheer amount of data that you're sending. So you publish a process variable, a temperature, a pressure, an RPM, and now it's stateful. We know that's the last known good, so we don't have to publish it again until it changes. The other thing that people don't realize is that you get much faster response time with report by exception. So if you have a lot of statuses, let's say a valve status or a machine status, well, on your edge, that means now you can pull that at a very high rate. And as soon as that changes, you're going to publish that into the MQTT infrastructure. So instead of polling round robin, you sit there very quiescently until something changes and then you report it. With MQTT, you get one-to-many communications now with your infrastructure. You decouple your data producers from your data consumers, and you get to leverage the zero trust security of MQTT. With MQTT, your remote assets in the field, at the factory, at your plant, make a remote originated connection using TLS to an MQTT infrastructure. So instead of trying to protect 100 or 1,000 assets out in the field on all those ports, you get to protect one port on your MQTT server. It's been out there, it's tried and tested, it's been out there for over 26 years now, and it's kind of a common technology that can be leveraged both by OT and IT within your infrastructure. Very quick about Ignition is that we all know that Ignition is can be a lot of things. It can be SCADA, it can be HMI, it does reporting, it does alarming, it's got its own time series database. But really, when we look at it, it's a tool for enterprise connectivity. It gives us the ability to pull in raw data, whether that's at the edge or at a gateway, and then take the tools within Ignition. One of the most powerful aspects of Ignition is the fact that we can gather our tags, get that raw data, contextualize those tags, then start building UDTs with those tags, basically creating a digital twin that we, the customer, controls, and also keeping track of all of our real-time data changes. Now, on top of that, when I do seminars or go and talk about MQTT and how widely adopted it is, it really comes down to it's super simple. It comes out on Raspberry Pis with Node-RED, and you can publish anything you want on any topic, and it's secure. But the problem is you can publish anything you want on any topic. And so when we first started in this with the inductive, there was this kind of, we do MQTT, we can do MQTT, but if you went in and you subscribed to something, there was no common way to do that. So very simply, Sparkplug does 4 basic things. Number one, with an OT-centric topic namespace, the result of that is plug and play auto discovery. We know what we can subscribe to. We publish that. Now we know when we get a message where it came from and probably what the payload is going to be. The second thing is that we can publish a model or an asset from the edge. That really opens up this whole world when we start talking about the UNS. If I can publish my UDT from the edge and discover that within infrastructure outside of that, that allows me to start basically doing digital twins and publishing those as a single source of truth from the edge. Once we get each process variable into our cloud, like a Snowflake, for instance, we have efficient encoding of our process variables. So if we go look at one measurement because of the UNS that we're publishing into, we know where it came from, we know its name, value, engineering high, engineering low, timestamp in milliseconds, and anything else we want to decorate that tag with in Ignition. And finally, we get state management with Sparkplug that's properly defined. If we lose our connectivity with the Ignition modules, we can go into store and forward, put those into a store and forward queue with the timestamp. So when the network comes back up, we can backfill that information into the time series database. So when we look at that, here's Ignition. We've got our raw tags going in. Then we use the UDT capabilities to create our models, instantiate that, creating assets. Now, the MQTT transmission module can go find all that information using Sparkplug and publish it to any available MQTT server. The resulting architecture looks something like this. We could go from Ignition Edge, Ignition at the edge, publish that into an MQTT server. From there, we could pick it up with Ignition. All of a sudden, with no coding, all of that just automatically gets populated within Ignition. And then we could go to something like Snowflake using the IoT bridge for Snowflake. But instead of this nebulous drawing, I'm going to pass this off to Benson, and we're going to look at a real Ignition edge, a real Ignition at the edge, and see how that can come into our infrastructure. So Benson, I'm going to hand this over to you.
So thanks, Arlen. Hopefully everybody can see me. Welcome, of course, and thank you for joining us today. We're thrilled to be here presenting with Arlen on kickstarting your UNS. So real quickly, for those of you who may not be aware of Opto 22 or our technology, we're a California-based, privately held manufacturer of industrial automation hardware and software, 5 decades of experience, installed base in the millions at thousands of customers worldwide. Our company was started by engineers, and we continue to be run that way 50 years later. That combined with world-class reliability, ease of use, and unmatched customer support are really the markers of our DNA. This is where I'm broadcasting live from our demo studio at our Opto 22 factory in Temecula, California. It's about an hour north of San Diego. It is where we design, build, and support everything we make. And the OT data I'll be presenting in this webinar is real live I/O controls and legacy PLC data originating in this building, including the facilities portion of this building where we're monitoring things like energy and compressed air. I'll be giving you a demo of that. All right, some of the demos I'm going to be showing are actually available publicly as well. So here's a few links. You'll be getting this presentation, so you can click on these links and check out those demos for yourself. So we're going to jump right in here. And first, what I'll do is brief you on the 3 distinct use cases for getting your OT data into a UNS. The first is a simple machine monitoring application using Groove Rio connected to an ignition gateway, and then MQTT Sparkplug B, we're going to send that up, as Arlen described, to a Chariot MQTT server. From there, we'll get data into Snowflake. Arlen will show his own Ignition 8.3 instance, subscribing to all those tags as well. My second demo is showcasing how we're monitoring, again, the power and energy from our own factory and getting that data to personnel in plant while simultaneously getting the data to Snowflake, to Arlen's 8.3 instance again, and also to an online demo hosted by Inductive Automation. I'll be showing you that demo here coming up. And finally, our third demo shows how we're able to connect, collect, store, and visualize legacy PLC data, all 100% securely, ultimately reaching those same 3 applications again: Snowflake, Ignition on another server at demo.groove.com, and of course, later we're going to see Arlen while he connects to that broker and collects all this information himself. Okay, to meet the objective, we're going to use 3 different Opto 22 Groove products: Groove Epic, Groove Rio, and Groove Rio EMU. First is Groove Epic, a real-time edge programmable industrial controller. Yes, Epic is an acronym. And we'll also be showing you Groove Rio, or what we call I/O for the IoT, and so much more. Now, very briefly, Groove Epic is an all-inclusive edge-based controller, HMI, gateway, and much more in a fully web-managed, cyber-secure platform. And it includes an array of built-in software tools with advanced gateway functions, all built upon a Linux-based quad-core compute platform that's designed for challenging factory installations and, of course, remote sites. I'll also be showing you an implementation of Groove Epic with no I/O, performing just the task of a gateway and running Ignition. Groove Rio is a compact standalone Ethernet I/O module that's nearly infinitely configurable for just about any I/O signal you have. These units are ideal for machine monitoring applications, and at the end of the webinar, Dan will feature a case study of a Tier 1 automotive supplier who delivered plant-wide OT data to their UNS using Groove Rio. And finally, the Groove Rio EMU. Similar to the Groove Rio in fit and form, but its function is to connect and collect your electrical loads, energy, and power data to get it into your UNS for cost savings and, of course, machine health. And we're actually doing this in our own facility here at Opto, and I'll demonstrate that live. And it's a good time to start the demo. So let's get started. I'll switch over to my browser screen here and switch my cameras around so you can see what I'm doing. Okay, the first one is Demo 1, machine monitoring. Let's take a closer look at what I'm working with here. And so what I have is a Groove Rio on my little Rio workbench. And this is simulating a machine where I've got a stack light here so I can actually monitor the status of the machine stack light. I've got a temperature sensor here that's wired to the top, and also a proximity sensor so we can measure machine counts. So this is all real I/O. This is connected to the network, and it is indeed using PoE. And I've got a number of other signals in here as well. So let's take a look. I'm going to switch back my screen. Here we go. And I'm first going to log into this Rio and show you how that I/O is configured. And then we'll log into Ignition running on my desktop. So first, the Groove Rio. I've already logged into these. They're all secure devices, require a username and password, but I want to get right into it. So here's all the channels that are coming from this Rio. So I've got temperature, part count, whether the machine's on or off, and also all the statuses for those stack lights that I can see coming on or off. So that's pretty cool, but how did I get there? Well, let's drop in here into part count and click on configure, and we'll show you how this is done. First is the name. Now, this is the beauty of MQTT and these kinds of architectures. I'm going to give this IO signal a name, and it will be the single source of truth throughout my entire system. So cool, I've got my name in there, then I select my channel type. In this case, the proximity sensor is a 5 to 30 volt DC input, but as you can see, I can configure that channel for a myriad of different types of signals. Very cool. So one part number, lots of different options. And then this is wired to channel 1 of the Rio, and on digital endpoints, it gives me even more features. So in this case, I want to configure this proximity sensor to be also a counter. Now, finally, I need to provide public access. So this is saying that I want to take this data point and send it up or make it available through a lot of different protocols, MQTT, OPC, REST API, and much more. So I set the status for read, and then I also want to send the counter value as its own process variable. And I make it writable so that I can actually write to the counter and say, clear it after a shift or at the end of the day. So pretty cool there. My IO is configured, there you can see it, and I'll go ahead and test it. I'm gonna take my proximity sensor and simulate machine parts going by, and as you can see, I've got it there, and my counter is going up as well. So we're at 40 there. Fantastic. So you may be asking, Benson, how the heck did you wire all this stuff, all of these signals up? Well, we've made that easy too. We've actually included wiring diagrams for all the different signal types that are supported by Rio, so you can quickly get up and running. Okay, I've got my IO configured, everything is landed, I'm in good shape. Now I need to start sharing that data. For demo 1 here, for machine monitoring, I'll go into data service, and what I'm gonna show you is all the data services that are available. In this case, I'm actually gonna use OPC. So I go into OPC, I click a couple radio buttons, get it set up. I can set up security or not. I'm on a trusted network here, so I don't have security turned on. And then this endpoint is the key thing that I need for any OPC client to start getting this data. So let's run over here to Ignition, which is running on my desktop in a Docker container. So it's the latest version of Ignition. You can kind of see the overview there, and we'll jump right in to config, come down to OPC connections, and there it is, the Rio Workbench OPC UA server. And if I take a look at that endpoint, you can see where that endpoint becomes important. I just put in the name of the device, and I'm now automatically able to browse all of those tags and pull them into my Ignition gateway. Once they're in the gateway, I can now go into Ignition Designer on my Docker container, and I've created a folder called MQTT tags. Pretty simple. And then there, I put another folder for machines, because I may connect to a number of different machines with this gateway. And then finally, I have a UDT for this Rio that I've configured where I instantiate it here. Well, let's take a quick look at that UDT definition. And here it is. So I can folderize and take all of those tags that are coming in through OPC, and I map them directly to my UDT. So when I instantiate the UDT, I give it a name, in this case, machine 1, and then I get all of my process variables and states automatically pulled into the UDT. But here's what's important. I also can set up parameters on my UDT that allows me to add context and modeling information about the asset I'm actually monitoring. So in this case, it's the name, which OPC UA server, the location of that particular device, what its name might be, maybe even a machine number. So now when I start sending my data to Arlen and he subscribes to that, he's got rich contextual data that gives him all the process variables. There I can see a temperature. I'll go ahead and put my hand on the thermocouple and we'll warm that up, and we should see that starting going up a little bit. It's pretty warm in here. And then of course my proximity counter now is also in here. So as I start clicking more machine parts, I'm getting that data. Great, everything is in Ignition on my local desktop. Let's get it to Arlen. So I'm gonna switch back to the gateway, and I'm gonna scroll down to the first Cirrus Link module that fits inside Ignition, MQTT transmission. It is indeed enabled, and here's my transmitters. And just as I said, I put everything in a tag path. on MQTT tags in the default tag provider, and I'm sending all that data up on an MQTT namespace, a Sparkplug-B namespace. Starts with Opto 22, production, then it'll go machines, machine 1, and the folder extends from there. So Arlen will see exactly where this is coming from with all its information. Also, I've set up a server. So Arlen spun up a server for me, a Chariot broker. I connect to that securely with a username and password, log in, and I'm connected. So that's essentially what I've done for machine monitoring, and then Arlen will show you that data flowing into his system. Got to jump to demo 2. This one's a little different. In this case, we are using a Groove Rio to connect to the service meter that's coming into our building so I can see all the energy that our building is using. But I've also used Groove Rio emus to connect to huge compressors that are here in the building that are providing compressed air to our manufacturing with CTs and voltage. I pull those right into here, and then what I'm doing differently this time is I'm actually going to use MQTT rather than OPC to publish directly from these Rios into an epic. So I'm going to scoot this thing out of the way, and I'm going to bring over my epic that I'm going to log into. There it is. This is pretty standard epic with chassis 0, no IO. So we're just using this to run ignition, and it's also providing visualization. So there's an HDMI cable connected to my epic to the screen over my shoulder, so I have real-time view of everything that's going on. And that also provides local visualization to anybody in plant that needs access to that facility data. Then I'll configure this and go into Chariot, and we'll get it on its way. So first I'm going to log into the Rio Emu on compressor 1. I'm going to click IO, and as you can see, the IO looks a little different. In this case, we've got 64 channels of rich power and energy consumption data all listed right there. Pretty sweet. And yes, once again, we do provide a wiring diagram for wiring up your loads. Great. Now I'm going to go in again, like the machine monitoring, I'll go into data service. And in this case, I'm configuring Sparkplug. So I want to come into here, and I just give it a group ID, edge node. In other words, I'm creating my namespace for my OT side of the network to publish all that data into a broker, which is running on this epic. And that's the MQTT distributor module. So to get there, we're going to actually first log into this epic. Here it is. And as I said, this one has no IO. So I'm logged into EMK001. And basically what I need to do now is just jump right into ignition. So if I go there, this ignition is completely built into all these products. So in this case, I can choose which edition of ignition I'd like to run. And on this particular use case, I'm using full ignition, but I can use ignition edge, which I'll do for the next demo. And I just open up ignition. I've already got it open up in a tab and logged in. This is now ignition running on the epic. So now what I want to do is, again, go to config, and let's take a look at some of those modules that makes all this work. The first one is the MQTT distributor module. This is essentially the broker that's running on the epic. So all my Rios out on the plant floor are publishing their data into here through the distributor. And I set up users, and I can have a secure connection. Second, I'm going to have MQTT engine, again, on this epic that's subscribing to all that published information. And now I'm going to use engine to actually build out my UDTs. So we're going to swing over to designer that's on this epic. And first we'll go to MQTT engine, where you'll see those edge nodes that are coming in from my devices. So that's down on the OT side. Now I'm going to swing back to the Snowflake folder, because this is part of our Snowflake demo, created a folder called Snowflake tags, and then created a folder called energy. And yes, once again, I actually created additional folders and started to put all my UDTs in there. The UDTs are instantiated here, but the raw UDTs are right here as well. So in this case, I can see my Rio Emu, my Rio KYZ, and all of these UDTs are available for free up on the Ignition Exchange. So you can download these and use them yourself in your own application. Now, once I've instantiated, I call it compressor 1. And once again, I can start creating rich contextual data about the asset that I'm monitoring. It's compressor 1, it's on the manufacturing first floor, it's configured in this way. All that information is already part of the UDT. And then of course, I've got all my data in there, both energy values energy intervals, and even power. So terrific. I've got everything loaded in here. I've got all real-time values coming in. None of this is fake. This is the actual compressor that's running. So now that I've got everything sitting in that folder, again, in the Snowflake Edge Provider, Snowflake tags, I'll go back to the gateway configuration, and our final MQTT module from Cirrus Link Solutions is transmitter, similar to what I just showed. I'll go to transmitters, and there it is. Tag provider Snowflake, Snowflake tags, and we're going to publish this information as Opto22 facility, and then energy and devices and so on. So pretty much all done there. Now you can see I've got a number of other transmitters in here as well. So I'm actually publishing data to a number of different brokers simultaneously with this system. In fact, one of those I'm sending to one of the brokers I gave Travis over at Inductive Automation access to. And so he used Engine, pull it in, and developed this really nice interface of our building. So in this case, we've got the compressors overview, we've got live video of the equipment room so we can see what's going on. And of course, I've got all my data in here as well from my 2 compressors coming in. One compressor is running, the other's in standby. So pretty slick. We got all the data up to an application. Okay, finally, my third demo. This one is going to be focused on getting legacy PLC data. So for that, I'm actually going to switch my screen and once again give you a better view of this. So behind me, I've got an Epic connected on its own network segment to a couple of legacy PLCs. These provide no security. They're just standard PLCs running on an OT network. Then I've also got a control program running my Opto turbine, local visualization, and then through my other network interface, I'm going to publish that data out. So that, of course, is represented again here in this drawing. What I'm going to do is log into this Epic, the one that's behind me here, and show you how that was configured. So I'll go in there. Now I'm on Epic DC008, which just is the host name for my device. Yes, I have I/O. I'm actually doing an Opto turbine application here. And quickly, we want to take a look at the network because we have a lot of network gateway functions in here. In this case, my Ethernet 0 is my manual or static network where my PLCs reside. So typical OT, static IPs and so on. But on the other network interface is my valid gateway to get to the broker that in this case is running in the cloud. All securely, all outbound, no open ports. And then of course I have a VPN tunnel in here. This is all built in so I can access this from anywhere. We're going to jump right into Ignition. In this case, I am running Ignition Edge. So when I open up Ignition Edge, which I have open in this tab here, looks like I got logged out on this one. So we'll log in real quickly and we'll get to the view screen so we can see what the status is. And as you can see, Ignition sees all 3 of those network interfaces, the VPN, the static network, and of course the gateway network. Terrific. So now that I've got all my information in here, well, how did I connect to the PLCs? So this is Ignition Edge running on this Epic connected to the PLCs. And for those of you who know Ignition well, you've done this a million times. So I'll quickly go through it. And there you can see my device connections. These aren't OPC. These are basically the built-in drivers to Ignition for Allen Bradley, for Siemens, and even our own local control program running on the Epic. So in essence, 3 different PLCs I'm connected to. If I edit that, you can see I can just go right to the IP address of the Allen Bradley PLC, pull in all the tags. Let's get modeling. So we're going to go right over to Ignition Edge Designer now. Same idea. I've got webinar UDTs. I created the special for this webinar. And in there, I've got a folder called turbines. And once again, you guessed it, I've created a UDT for this entire system all in one. And there's all the data. I've got parameters about where this turbine is located. I've got Cal ISO data flowing in that I connect to and pull into the system. I've got my 3 PLCs and all of their data, process variables and tags, but it's all contextualized, modeled, and sent up as essentially a UDT templatized thing, again, to Arlen. So quickly, I'll go back to here. And one of the things that we've done in this instance is I'm publishing to my own broker and to Arlen's broker, but this one is actually a broker running in Germany of all places, and it goes to an application, an Ignition application, and then to our own OPC UA client, which is one of our free live demos. I'll click quickly into there. There's your screen. You can log in and perform any of these functions yourself. Here's the turbine control. I click on it and boom, the turbine starts. And then as we can see, there's a couple of stack lights right over here. The green one is Siemens. The red stack light's tied to the Allen Bradley. Bidirectionally, I can send information through Germany back to here, and it turns on. It's astonishingly fast, highly secure, no open ports, all encrypted, all authenticated. So pretty sweet there.
So Benson,
Yeah.
I'm in Stillwater, Oklahoma. I'm gonna turn that red stack light off right now.
Okay. Yep. You just did it.
There we go.
So yes, because I've given you access and you have the rights to get to this system, you can interact with it if I choose to make those points writable. But obviously, with a single checkbox, I make the entire system read-only as well. So I've covered three. Let me turn off my turbine. It's kind of loud in here. I've covered three demos here. First one, machine monitoring with a Rio connected to Ignition on-prem and a Docker container. Collected all that data, modeled and contextualized it, and sent it to the Chariot broker for others to consume, including Arlen and Snowflake. Second, I connected to our facility information here, compressors, power, air dryer, and so on, pulled that in to this epic on my desk, and then pushed that as well under a different topic namespace. And finally, I did a legacy PLC integration where I used Ignition Edge and its drivers to connect, collect, model, and publish to the Chariot broker. And Arlen, it's all yours.
All right, thanks, Benson. Awesome demo. So I'm gonna make myself presenter. I am, as all of you know, Ignition 8.3 just came out, and we got our MQTT modules done for 8.3, and the layout's really nice. I'm not, this isn't a webinar to go through 8.3, but here I've got my MQTT engine settings, and you can see right now that I am connected to the same MQTT server that Benson's connected to. And so what I can do is go into Ignition Designer. And as we started this demo, I didn't know anything about what Benson was doing. And as he brought things online, I started seeing UDT show up. So here's my Opto 22 UDTs. Here's the Ignition Gateway, the Opto Turbine, the Rio emus, and the Rio KYZ definitions. Now, the resulting unified namespace, if you will, is Edge knows Opto 22. From Opto 22, I can go into facility, and all of a sudden, here we see compressor 1, compressor 2, the service meter, and the real-time KYZ data coming from that. Now I can drill down into production now. And remember, Benson told you he had all of those parameters in machine 1. So here I didn't know anything, but I can go, okay, well, what is that, Benson? Well, that is machine 1. It's on the Rio workbench. It's running the demo studio, running in the demo studio. It's called the Benford 6100, and the name is the Rio workbench. And then I can drill down into all of those process variables that Benson defined in his UDT, and we can see all of those and all of their statuses immediately. So really cool. And remember, this is all a single source of truth. So I didn't know anything. I connected my engine to Benson's, the same server Benson's connected to, and all of this data is coming in. And like I did before, you saw it in the video, is I could go into his Opto turbines, go drill in and find that, into the turbines, and go find that Allen Bradley PLC right here. And that's what let me go and turn the stack light on and off remotely. So we've got that. And then finally, so, if you kind of like what Walker Reynolds says in his, kind of UNS is you've got to connect to your machines, you've got to collect the data, and you've got to store it somewhere. And you've got to be able to show a best-in-class real-time operational system first and foremost. But the advantage here is that we can also start taking it somewhere else. So we've got the IoT bridge for Snowflake installed. And when we installed it, it literally went into Snowflake with proper permissions, and it created two very simple databases, a node database and a stage database. And in the stage database, we can look in our tables here and see that we have a Sparkplug raw table where all of the Sparkplug data is going. 100%, we're not ripping anything off all of that valuable data that Benson's sending. And we've got a schema. So if you aren't familiar with Snowflake, it's basically an SQL database on steroids. So we have all this raw Sparkplug data flowing in for every message is published, that lands into an SQL database. But then we've got stored procedures to pull that up and start doing something interesting. So here I've got the Opto 22 facility and views of all of this information. I've got the Opto 22 turbines, and I've got the production that he had on his Rio. Now, before we look at these views, the other thing that we were able to do is I'm able to go in and ask that SQL database, well, Benson, what are the models that you publish? What are those UDTs? And I can come in and say, well, okay, I got a Rio UDT, I got a KYZ UDT, an EMU, an Opto turbine. I got all of these UDTs published. So now I know what's in that schema, the setting in my Snowflake raw table. So now I can go out and I can build out views of, let's say, the KYZ. So I come in here, look at a data preview. I've got, again, we didn't write a single line of code. We were sitting quiescently, listening to that MQTT server. And all of a sudden, we got a birth message. The birth message contained the UDT definitions. And so maintaining my unified namespace of Opto 22 facility, energy, load, service meter, I now have all of that data populated. And notice all the columns are hydrated with information. Now, if we go and look at the raw MQTT data coming in, you'll see that we've got a lot of nulls coming in. Well, why? Everything is report by exception. So we're taking up 80 to 95% less data, but using the time series capability of the Snowflake, we can hydrate those columns. So now I could point this at Power BI, Grafana, Tableau, or any analytics, excuse me, that I want to run on this data. So really, I wanted to show that. I'm going to get a drink. Okay, I wanted to show that information. And now we've basically shown everything, that single source of truth from the edge in Benson's factory up through into a gateway, showing all that data, and then taking all that real-time single source of truth data into Snowflake. Pretty awesome demo. So with that, I think Dan's got some really interesting kind of case studies on where this has been used for Opto. So Dan, I'm going to make you a presenter right now.
Thank you, Arlen. Really cool stuff, you guys. And I'm going to actually be sharing one case study. Let me know if my screen's up.
Yep, see it.
Great. So Moriroku Technology North America, or MTNA for short, is a great example of a high-performance manufacturer with a lot of legacy complexity. So let's take a closer look here. They're a Tier 1 automotive supplier with 4 plants across the U.S. and Canada, where they make plastic parts that end up on vehicle dashboards, on body components like trim and spoilers and so on. Well, after the pandemic hit, and we've experienced this ourselves as a manufacturer, lots of supply chain challenges there, and it exposed some weaknesses in MTNA's inventory tracking and reporting. So that led their management to launch something that they called their Vision 2030 initiative. The goal was to achieve better visibility into what's actually happening on the plant floor, to see everything in one place on a single screen. So they decided to start at really the heart of their operation, which is their injection molding machines. But for their engineers, unifying over 100 machines across 4 different facilities really seemed like a lofty goal. They wanted to get everything into a single unified namespace, and they were like, how do we even do this? This is a great example of a customer who came to us with this big picture goal, and we were able to help them, using both our products, Arlen's Cirrus Link Solutions products, as well as our partner Inductive Automation's Ignition platform to help build the digital infrastructure to get there. So what were they up against? Every site had 20 to 30 different injection molding machines. And since each of those facilities came to MTNA through various acquisitions over the years, nothing was standard. Some machines, basically machines were all manufactured by different companies. They had various control systems and supported different communication protocols, if any, right? So standardizing data collection didn't even seem possible. And for that reason, they were really doing it all by hand. Operators were literally writing down machine statuses and batch statuses every 15 minutes or so, or at the end of each cycle. And so you can imagine how that slows things down and, of course, introduces the probability, really the certainty of human error. So there was no real-time visibility. All the reporting was delayed. If anything went wrong, they'd only find out after the fact. And of course, by then it was too late to prevent a downtime scenario. So they wanted to solve the problem. They didn't want to have to refit every single machine with new controls. We know how expensive and time consuming that is, and that just didn't seem like a good solution. So they were looking for something that was flexible and vendor neutral, something that wouldn't lock them into a specific ecosystem. And that quote from Martin on the right really sums it up. They needed something that could bring everything together, but without making things more complicated. So they started small. At their Rainsville, Alabama plant, they actually ran a pilot using a single board computer. In this case, it was a Raspberry Pi, just on one machine, just to see if they could capture the real-time data that they wanted and reliably publish that data. And of course, it worked. But the prototype proved out in concept, but it really exposed the limitations of using a consumer-grade device like a Raspberry Pi, which is really designed for educational and hobbyist use cases. It wasn't rugged enough, it didn't support analog inputs, and it would have required too much configuration and IT overhead to put hundreds of these things into production. That's when they found us, they found Groove Rio, and it really checked every box for their application. It was industrial grade, it had plug and play, flexible I/O, this built-in data service, which you saw some of which Benson shared a minute ago with a built-in MQTT client, Sparkplug B publisher, so that they could securely and efficiently publish data where it was needed, when it was needed. And the cherry on top, at under $1,000 a piece, it was affordable enough for them to scale this across their entire enterprise. So they focused on capturing just the key signals that mattered for an injection molding machine. Was it in full auto mode? Were there mold changes happening? What was the water flow, open and close cycles? Simple signals, just like Benson showed you on the desk there with proc sensors and temp probes and so on, but crucial for tracking cycle time and availability of their machines. So using those RIOs, all that data was published up to Ignition using MQTT Sparkplug B and aggregated into a unified namespace, which was ultimately enabled by Cirrus Link's MQTT distributor module running in an Ignition environment up on a Microsoft Azure cloud. Because each machine could use one RIO and the setup was so consistent and repeatable, they were able to scale over 100 machines in just a few months. So how did they actually do it machine by machine? This is the basic setup. Each machine, as you can see here, has various signals like mold ID, status, flow, and so on. Lost my mouse. And then using the Groove, each machine's got a Groove Rio installed nearby. So typically they would install that Rio in an existing electrical enclosure. And using the Rio's configurable I/O that Benson showcased, they were able to collect those key signals. And with just those few critical data points, now they know is the machine running, how it's running. The Groove Rio publishes that data up with MQTT Sparkplug. Each device is a self-contained publisher with built-in encryption, SSL TLS, and this onboard data service. So the big takeaway here is that it didn't require rewriting PLC code or even touching an existing control system. Just a fully bolt-on vendor neutral solution for about $1,000. So that's what one machine looks like. Here's the full rollout. They took that same architecture, put it on each machine with MQTT Sparkplug, and they published that data first to a local on-prem Ignition server, where they would then model and contextualize that data, and then ultimately up to the cloud-hosted Ignition server. So here you can see sites in Rainsville, Anderson, Greenville, and Listowel. Each plant has its own set of machines. Each machine has its own Rio. They publish data directly into Ignition. And then, doing this, they're able to use the exact same format. So each machine's data looks just like its next door neighbor machines across all the facilities. So the key here is the repeatability. Once they had that pilot up and running, they with the Rio, they were able to just replicate that setup, no rip and replace, no special code, no vendor lock-in. And this gave them the digital foundation to move forward with more analytics, like what we saw in the Snowflake cloud and so on with Arlen. Being able to report all that data and get everything in, it really fit into their Vision 2030 plan, and they were able to just lock it down in just a few months. And so what did it all deliver? Well, there's the screen right there. They eliminated all that manual reporting, no longer need to log status data every few minutes. The system reports live in real time. The Ignition dashboard that you see here shows stakeholders in both management as well as operators and engineers in the facility real-time access to production metrics down to the second across all their machines. Limited their cycle time variance. They're now able to spot issues faster, which helps them stay on target and avoid production delays. And just as important, this system is now ready for what's next. So they're already exploring the possibility of adding more Rios to paint lines, to vision guided systems, to quality control systems, and predictive maintenance systems. So, it wasn't just a one-off project. Helping them build out this UNS architecture now creates this foundation where they're able to standardize data across all their facilities, making it easier to integrate and easier to expand the scale as they go forward. And with that, are we at the end?
Yeah.
Yep, we're good.
Good job.
Awesome.
Nice.
So in summary, I mean, really, Benson, Dan, I really appreciate you guys jumping on. So really what we've seen is, we wanted to make this a real webinar with real, single source of truth equipment at the edge, publishing that into an MQTT infrastructure. From there, being able to take that both to Ignition and to data cloud platforms like Snowflake, and really show something that is really doable. Everything that we just showed you from an Ignition standpoint, you can download it and do it this afternoon. Then if you need IO, you can get a hold of Benson, get some Rios, for less than $1,000, and just start putting together, try to solve that single problem. You don't want to eat the elephant, but you want to be able to take, kind of this blueprint that we presented today and to be able to scale that out. So with that, Kurt, do we have any questions?
I think something that I've seen a lot of people, and even outside of this webinar, just what is missing on the UNS. I think a lot of people look at the UNS as a way to just structure and lay out your data, but that's just one part of it. If there's something that I think is critical to making it work, I think outside of just the organization, what would that be? What are you seeing? And for more of the implementation of the projects that we're doing.
Well, I think Benson and I can both address that. But from my standpoint, I just saw it the other day on my LinkedIn, is that, hey, this whole UNS thing, there's no standardization around it. I really don't see what its benefit is. And really, when I think about it, like I said, I've been doing this for the last 46 years. And for 35 or 40 of those years, we basically took tags and we dropped tags on screens, and the value hit the screen, the operator looked at it, and the data fell on the floor. That's it. And then, all of a sudden we started getting this notion of, it's going to be the industrial Internet of Things. How are we going to do this? And those systems that were basically discrete point to point were never going to scale. And so we backed up and we took a look at this and said, wait a minute, we've got to start taking that data from the edge. Yes, it's very important to get it in front of operators, but now we have to contextualize that and get it up to the enterprise where people can get a wider view of what we're doing. Now, I'll give you a good example is that we have things in the oil and gas industry like enumerations. Well, we have an enumeration. What did we do? We built a screen, and if the enumeration of the orifice plate material of a flow computer was 0 or 1 or a 2 or a 3, we said, okay, well, on the screen, if it's a 0, we're going to display stainless steel. If it's a 1, we're going to display Monel. But then when that integer value went up to IT, guess what? It's completely, they have no idea what that is. So our job within a UNS is to contextualize that so that when somebody sees it in IT, they don't go, oh, well, gee, that's we don't know what that is. We're going to have to, it'll take us, a week to actually figure out what that value is. So, I think that's one aspect of what is a UNS. And then Benson, I'll let you take it.
Yeah, thanks, Arlen. And from my perspective, I subscribe to the theory that, if you look at what the tenets of a UNS are, and this has been described ad nauseum, and certainly Walker Reynolds does a terrific job of laying this out, but it is a real-time snapshot of your entire business. And real time happens to matter. And while a UNS can include a lot of different aspects of your business, including ERP, MES, and so on, our focus here has been on the notion of that operational data that we want to be able to get in real time into the UNS. And so one of the things that Walker says, and I absolutely believe, is those initial steps are critical. Connect, collect, and store. So we know that when the data lands in the UNS, it is a real-time snapshot of your OT operations, and you're able to share it in a contextual way for others to consume that data and do something interesting with it. And it could be a combination of OT data along with maybe production or quality assurance, all kinds of different things that we can pull into a standard format that, again, is still that real-time status. And so that's what we've tried to demonstrate here is that notion of being able to use these off-the-shelf tools and open standards, Ignition, MQTT, TCP/IP, and standard methodologies for exposing this data in a meaningful way by contextualizing and modeling it and landing it in the UNS so we can start really accelerating our digital transformation efforts within an organization and see some of the results that we saw from MTNA that Dan showed off in that case study.
Great answers there. I guess anything that you see, I think a lot of times, I don't know how much you went over security, but that always becomes a question. And looking at this, from IT, from operations, security is always a huge point of this. Anything you can highlight on that?
Yeah, I'll start down at the edge. When we put together these products and tried to build them in a way that could, they could actually run these standard tooling, OT type tooling applications, including, Ignition, including the Cirrus Link modules, maybe other aspects of their Node-RED and so on, we realized how important that security was, and it couldn't be bolted on. It had to be baked in. And further, we tried to do this in a way that created less reliance on a bunch of other third-party products to provide that. Now, because MQTT is a publish-subscribe model, this allows us to push data from the edge into the broker infrastructure. What that means is that I don't have to open any firewall ports. And yes, all the Groove Epic and Rios have firewalls, and we close all those ports down so you can't access the device directly. The idea is that we're going to connect, collect, store, and model the data at the edge, and then push it out to infrastructure over standard TLS, SSL. We don't talk about SSL much anymore, but TLS over TCP/IP. And I think this is important we hear a lot about security and MQTT, that security wasn't baked into the MQTT protocol. Well, that was by design. It's the same as your bank doesn't bake in security. They use standard TLS security for making sure that when we do transactions with our bank or a Google search or whatever, that those are authenticated and encrypted using technologies that are open and standardized. So from a cybersecurity standpoint, there's no better footprint for maintaining that high degree of cybersecurity than this publish subscribe architecture.
Right. And Vincent and I always say that we enjoy, I mean, when they say, oh man, we're going to have to talk to IT about security. Hey, we enjoy that discussion because we can really talk at that level about making your infrastructure secure.
All right. Well, I think the time's coming to an end. Again, thank Vincent, Dan, and Arlen for this presentation. Appreciate everybody joining, and look forward to helping you guys on your UNS journey. Thanks again.
Thanks, everybody.
Thanks, Arlen.